Okay, welcome back. This is our second video on our chapter about risk management. And so we're beginning to talk about information gathering, essentially trying to figure out what are all of the potential risks facing a project. We talked about how you want to involve a lot of stakeholders. A lot of people with different perspectives will have different opinions and think of things that no one person would likely think of. So that's part of the process, this information gathering, brainstorming, what could possibly go wrong, identifying all these potential risks. Of course, not all risks have the same potential consequences. Some are very threatening, others pose less of a threat. But in the brainstorming session, you would want to just think of as many examples as you can. And sometimes identifying one risk may lead you to realize that that could have sort of a domino effect, and that could trigger another risk, and that might cause another risk, and so on. So sometimes brainstorming these ideas leads you to think of more and more ideas. There are two analysis techniques that can help you think of risks. They are the SWOT analysis and the Delphi technique. So SWOT analysis we've talked about before. SWOT stands for strengths, weaknesses, opportunities, and threats. So this is basically just a formal way of thinking about those things, the strengths of an organization, what their weaknesses are, what potential opportunities are, and what threats are. And of course, opportunities and threats are both examples of risks. Another technique we haven't talked about yet is called the Delphi technique. And essentially this is just going to the experts in a particular field when it comes to identifying risks. So you would want to interview or gather information, perhaps have a meeting with a group of experts, get their opinions. Maybe you interview them all individually and anonymously, and then summarize their opinions, and then give it back to the experts for them to further analyze. So it's essentially the same as interviewing stakeholders, but it's a particular type of stakeholder, experts in a given field. And it's based on the assumption that these experts' opinions are going to be more accurate than the typical stakeholder. So as I said, sometimes if you think of one potential risk, that leads you to think of another and another. And so it's often good to try to organize these relationships amongst activities or risks. And so one way to do that graphically is with a flow chart, essentially connecting the potential risks in a visual format. One risk goes on to the next, and then that might branch off and cause a couple others, and so on. Another type of analysis that can be done to understand relationships among risks are root cause analyses. So essentially this is looking at why do these things occur? Why does a risk occur? And if you can sometimes drill down to the root cause and mitigate that risk or avoid it, then that will save you having to deal with all of the risks that result from that root cause. And then another term here that we need to be familiar with is trigger condition. So let me back up here. Advance that slide a little too quickly. So a trigger condition is basically just a set of conditions, a particular circumstance that may cause or increase the likelihood of a risk occurring. And so oftentimes, if we can avoid the trigger condition, then we avoid the risk itself. So once we have gathered information, we've identified risks, we've looked at the way that different risks can be related to each other and cause other risks to occur, we want to make sure that we document this all in an official document that we call the risk register. The PMI identifies or defines a risk register as the document containing the results of the qualitative risk analysis, quantitative risk analysis, and the risk response planning. It identifies all identified risks, including description, category, cause, probability of occurring, impacts on objectives, proposed responses, owners, and current status. So that basically summarizes everything we're talking about here in this chapter when it comes to risk. We want to identify the risks. We want to, we'll talk a little bit more in the upcoming slides about the difference between qualitative and quantitative, but we want to analyze the risks, understand why they might occur, come up with a plan to deal with it, and we may need to categorize those risks, looking at their causes, how it's going to affect the project. We want to come up with a plan for how to deal with these risks if and when they occur, and we want to assign an owner to each one and only one owner responsible for dealing with a particular risk. So in order to deal with risks, we need to understand more about them and their likelihood of occurring, as well as the impact it will have on the project. There are different types of analyses that can be performed, qualitative and quantitative. And the results of these analyses need to go into our risk register. So the risk register is a living document that needs to be updated throughout the project. Qualitative risk analysis is the more common type of analysis. Essentially, we just try to describe on a spectrum how likely a risk is to occur. Is it unlikely, somewhat likely, very likely? There's not a lot of numerical weight applied to this. It's more of just sort of a general description. That's essentially what the difference in the terms qualitative versus quantitative. We're not measuring or do anything especially mathematical. It's more just a description in terms of words of what something is like, what its quality is like. We also want to look at how big the impact will be. So is it, if the risk occurs, is it going to cause a major problem, or is this just going to be a relatively small problem that can be fairly easily dealt with? So qualitative risk analysis should be performed for all projects. It's not especially difficult to do and doesn't take that much time or resources to develop. Again, it's helpful to look at the causes and the cause and effect relationships, because if you can identify a root cause and then avoid that particular risk, you can also then avoid all of the subsequent risks that would be caused by that root cause. So it's really important to work your way back to really understand the underlying cause. There's an old expression that an ounce of prevention, sorry, let me get this right. An ounce of prevention is worth a pound of cure. And so basically that means if you can prevent something from happening, that's much better than having to fix the problem after it's already occurred. And that's true in project management. If we can identify a risk and prevent it from happening, that's going to be much more cost effective than dealing with the issue after it has already occurred. This is an example of a risk matrix. I've posted a video on risk matrices or matrices to Blackboard that explains them. But essentially, this is like the qualitative analysis I was just describing, identifies a potential risk as being low in likelihood, very unlikely, to potentially very unlikely. And if we organize the likelihood of the risk along the vertical axis, and then along the horizontal axis, we have the impact. If it occurs, will it be negligible or minor, all the way up to a severe impact on the project. So something that is very likely to occur that will have a high or severe impact on the project, that's a high risk situation that we want to definitely have a plan for. If something is not very likely to occur and it has little to no effect on the project, then we really don't have to devote a lot of resources to that particular issue. We can deal with it if it comes up, and if not, great. So the higher risk issues are the ones that we want to be more focused on in our risk planning. Another type of diagram that can be used in risk management is the fishbone diagram. It's used to identify cause and effect. And I think it's probably best if I just jump ahead to an example of it. So you have here the outcome, a potential late delivery of a product or deliverable, and then you've got all the different potential causes that factor into it. And sometimes this is called a fishbone diagram just because of the way it kind of looks like the spine of a fish with all the bones coming off of it. So we have, in this particular example, the machines aren't working, or the methods are used were not the correct methods. Our people are not trained. We have defective materials. These are all potential causes that feed into a potential bad outcome. Quantitative risk analysis compared to qualitative is bigger, more complicated, more time consuming, where we essentially do a real statistical analysis looking at measurements and numbers and come up with a more scientific or numerical based probability of risks occurring. So we can use a quantitative risk analysis to more accurately predict whether our project will be on time, on budget, completes the entire scope, and meets the quality criteria that have been established. I don't think I'm going to be able to finish this video, finish all of the material in this video, although I have a little over a minute left. So I think I'm going to stop here and finish it up in a third video.